Hey there, Calc students. Welcome back to Algeomulus Prep Academy. Today, we will be covering the washer method. The washer method is a technique defined by the integral from a to b of pi times f of x squared dx minus the integral from a to b of pi times g of x squared dx. The washer method is used to find volumes when there is a gap or hole between the area being revolved and the axis of rotation. For our first example, we're going to find the volume of the solid of the region bounded by the equations -1/2 x squared plus 3x plus 2 and y equals 2, all revolved about the x-axis. To start off, the first thing we will need to do is determine the bounds. To do this, we're going to set our two equations equal to each other, giving us -1/2 x squared plus 3x plus 2 is equal to 2. We are then going to subtract 2 from both sides, factor out an x, and now set each factor equal to 0 and solve for x. In the end, we should have x equals 0 and x equals 6. For our next step, we're going to create a rough sketch of our graph. As you can see here, y equals -1/2 x squared plus 3x plus 2 is shown in red, and y equals 2 is shown in blue. For our next step, we're going to mark the axis of rotation and determine which way to integrate. As stated in the problem, we will be revolving around the x-axis. To help remember this, draw an arrow around the x-axis as shown by the purple arrow in the picture. Now, we're going to draw a rectangle that goes from our top function, which in this case is -1/2 x squared plus 3x plus 2, to our bottom function, which is y equals 2. This rectangle represents one of the infinitely many slices that our integral will sum up in our equations later on. With our main rectangle set, go ahead and shade in the rest of the area and draw a second rectangle from the bottom function, y equals 2, that goes down to the x-axis to show where the hole will be when we revolve the function. As the last step in our imaging process, we are going to draw circles to help visualize the solid after revolution. As shown on the left, our circles are created by revolving our rectangles made previously about the x-axis. From our 3D representation on the right, you can see that a summation of all the outer circles creates our solid, and a summation of all the inner circles creates the hole. With our visualization process done, we can now start solving for volume, and I'll start by setting up our integral. Remember that volume is equal to the integral from a to b of pi times our top function squared, dx, minus the integral from a to b of pi times our bottom function squared, dx. As covered previously, our top function was y equals -1/2 x squared plus 3x plus 2, and our bottom function was y equals 2. Plugging these in, we get volume is equal to the integral from 0 to 6 of pi times -1/2 x squared plus 3x plus 2 quantity squared dx, minus the integral from 0 to 6 of pi times 2 squared dx. With our integral set up, we can now solve for volume. We said that the volume was equal to the integral from 0 to 6 of pi times -1/2 x squared plus 3x plus 2 quantity squared dx minus the integral from 0 to 6 of pi times 2 squared dx. Because these integrals both have the same bounds, we can combine the two into one long integral. We can then factor out a pi and simplify the rest. Using a calculator, our volume comes out to be 684 pi over 5, which is about equal to 429.769875. Rounded, this is about 429.770.
So our next problem asks, what is the volume of the solid of the region bounded in the first quadrant by f of x equals e to the x minus 1 and g of x equals 4x cubed about the y-axis. The next step that we have to take is to take the inverse of each function so with respect to y. We do this because the question asks to revolve about the y-axis, so we need it in terms of y. Afterwards, we set the new equations equal to each other in order to get the intersection points using a graphing utility. This is so we can get the bounds for the integral. It's a good idea to graph the function so you can have a visual. The washer method is about subtracting. In our case, we're subtracting the space from 4x cubed to the y-axis, as shown by the red rectangle, by the space from e to the x minus 1 to the y-axis, as shown by the blue rectangle, in order to get our intended space as shown by the black rectangle. This is what it would look like if you were to revolve it. It's not necessary to do this, but it's good for visualization, and it helps with understanding the washer method. Next, we set up the two integrals using our points of intersection as the bounds. To simplify it, you can combine the two integrals into one. Since some calculators aren't very powerful, it's a good idea to factor out the pi so you can save some time in the computing process. Another fact to remember is that calculators don't have an option to type y or dy, so when you plug it in, just replace them with x and dx. You'll still get the same answer since nothing else is changing. If you did it right, you should get approximately 0.183. Thank you very much for watching. Make sure to like and subscribe, and I hope you have an amazing day.